Everybody's excited about AC because it's a terrific one-two punch of a significant boost in performance, with it being the first version of Wi-Fi that's a gigabit per second Wi-Fi. And then that coupled with a great opportunity to start using 5 gigahertz, which is relatively unused up to now. So when you couple that one-two punch with a seamless upgrade path where you don't have to do anything with your existing equipment, right? You can continue to support that and start to add Wi-Fi certified AC gear. We made it really, really easy to get the benefits of AC. So everybody's really excited about that combination.
802.11ac is really a package of 4 different technology components put together. First, we're using wider channels. So not surprisingly, when you have a wider channel, you get to transmit more data. This does make it kind of hungry for spectrum, but fortunately, the government is working very hard to give us more spectrum, and so that's a really exciting change. The second thing is that we're having more spatial streams, so that's like having more lanes on the highway. In the beginning, it's the same as 11n, but we've got a plan to go from 3 to 8, with the obvious more than doubling you get out of that. The third thing is something called modulation. There's a better modulation. I could explain this, but there's no whiteboard, and I don't think people watching this video want that much calculus. So just take my word for it, you get about 30% extra there. And the fourth thing, called multi-user MIMO, is really where the excitement is coming. It's not out yet. It's something that we're beginning to talk to customers a lot more about. And it's the ability to take all of these streams you get and to send them to individual devices. So no longer will you be tying up the entire access point simply because you use a lot of small battery operated devices. And this reflects the trend that we have towards phones and tablets and small devices like that. We'll be able to serve them much more efficiently.
What we're expecting in 2014 is that 23% of the new devices that get shipped will be 802.11ac. And if you look at where we are in this upgrade cycle versus the one before it, 802.11n, we were at 11% at that time. So this upgrade cycle is happening faster than it did before.
There's a tremendous amount of excitement in the industry on the newest generation or 5G Wi-Fi technology, 802.11ac. It brings much improved throughput that will allow enterprises to increase productivity and run new business applications over wireless networks. But it also comes together with a whole bunch of new technologies and networking schemes like cloud management, managing many access points at scale.
You know, the 802.11ac market, I think first and foremost, I think about customers trying to keep up with this huge wave of new mobile devices, and users often bringing their own devices into the workplace. And for an IT department, how do they keep up with that from a network performance and capacity perspective?
Where you've got a mobile first in general strategy coming, and then more and more of those applications are being delivered from the cloud. So if you look at what that's actually going to do to a network, it's really going to drive upgrades for the wireless LAN. I've got more clients, more data going over that wireless network. But if that data is actually going to the cloud, it's also going to drive the need to upgrade that wide area network, because there's no point me offering you a gigabit connection over the Wi-Fi if you've got a very skinny backhaul to the cloud. So I think what we'll see is a big networking refresh driven by the proliferation of mobile devices and delivery of the applications to those devices from the cloud. And that's going to drive a Wi-Fi refresh, LAN switching with things like 802.11ac Wave 2 that can go multi-gigabit rates, but then also the wide area network, because now I need much bigger pipes to the internet.
Yeah, as wireless LAN grows, we expect it to pull along some switching revenues with it, basically like the aggregation layer that's coming with it. We're expecting kind of a ratio of about 8 or 10 users connect to wireless LAN, and that will consume 1 switch port. So you're having a pull-through effect on switching, as well as you know, the power and throughput requirements are different for this new switching layer. That's another driver to the adjacent market switching.
The first wave of 802.11ac access points was actually limited to about 1 gigabit of throughput. Now the second wave 2 of access points and radios actually can now get to the theoretical limit of 1.3 gigabits per second. And that poses a little bit of a dilemma for how to actually connect these wireless access points to the LAN. And because Ethernet goes in steps of tens. There's 1 gigabit Ethernet and there's 10 gigabit Ethernet. And so how do you actually connect these access points together? Do you use 2 gigabit connections, or do you actually go the big step to 10 gigabit Ethernet, which really would come with a significant power and cost penalty? And it turns out there is actually a quasi, it's not really a standard, but it's been implemented in Ethernet, which is a 2.5 gig version of Ethernet, which has been widely deployed to actually connect switches with processors for actually a number of years now. This 2.5 gig standard is actually extremely well suited for these next generation AC access points.
I think the example I'll give is, I see AC is like a Ferrari car. The question is, if you drive that Ferrari tomorrow morning to your office commute, are you going to get there any faster than a Toyota? You can drive a Formula race car at 200 miles an hour and faster. It has that engine, but you can't get that speed when you're driving on a highway which is shared by other users when you're driving to work. Your switching infrastructure has to be able to transport gigi traffic back into the core. If you're still living with a legacy 100 Mbps switching infrastructure, obviously that becomes the bottleneck.
Now the thing to consider when we're upgrading to 802.11ac is that there's a provision in the standard for access point uplink speeds that exceed 1 gigabit per second. Let's open up that lane for the Ferrari. We have a number of options to do this, but the easiest and most cost-effective way is with a 2.5 gigabit uplink. The second is to consider the infrastructure that we're upgrading. Environments like a university cafeteria, Starbucks, small to medium enterprise, we're looking at 8, 12, 16 access points, and a legacy cable infrastructure, possibly Cat5. We're not designing a data center here. We're designing a Wi-Fi network. So to optimally and most cost-effectively upgrade this infrastructure as fast as we can, we're looking at a low to medium port count Ethernet switch supporting 2.5 gigabit access points.
What we've seen today is a tremendous excitement about these new 802.11ac access points and what the potential they have to increase productivity, deliver more bandwidth, rich media over enterprise network. And it's really all about how do we actually get dedicated lanes, high-speed lanes, to connect these new AC access points that are actually now capable of delivering over 1 gigabit of speed into the enterprise lane.
We're pleased to see all the excitement around 802.11ac, and Vitesse recently announced the Sparks 4 family of Ethernet switches, which is ideal for 802.11ac upgrades. First, we support the optimal port count of 8 to 24, 2.5 gig ports to get that Ferrari some lanes. Second, we're building off the success of our proven silicon, the Sparks 3 and eStax 3 families, to add layer 3 routing and larger table sizes and the ability to flexibly and easily configure services at the network edge. That's really important for 802.11ac environments like retail, also the rapid adoption of Ethernet in the Internet of Things, and new markets where IT services are being outsourced like the small and medium enterprise. 802.11ac is a critical transition point in Wi-Fi networks, and Vitesse is making infrastructure upgrades seamless with the Sparks 4.